In previous sections, we have learned how to define the roadway network, traffic volume inputs, and traffic control elements for a basic VSIM model. In this section, we will learn how to select and define model outputs for analysis. VSIM offers a wide range of outputs and measures of effectiveness, such as delay, speed, density, travel time, and queue length. It is also very flexible for users to define which outputs to report and when, where, and how the outputs are reported. Simulation outputs can be reported for any time period and time interval, for any point location, for an intersection, along a corridor, or for the entire network. And simulation outputs can be reported for individual vehicles or aggregated by mode or by vehicle class. Depending on the evaluation type, simulation outputs can be displayed during a simulation run for online evaluation, or stored in text files or a database for offline analysis. In order to generate desired output, you need to activate the corresponding evaluation type and code necessary data collection elements in the network. In this section, we will learn how to define and configure some common evaluation types and see what the results look like. We will first learn how to measure travel times during a simulation run. Travel times can be measured for any user-defined road section in the VSIM network. Each travel time measurement section consists of a start and destination cross-section. The average travel time, including waiting or dwell times, is calculated as the time a vehicle crosses the start section to crossing the destination section. To define a travel time measurement section, first select the travel time section's icon on the toolbar. The icon is the one in the shape of a clock. In this example, we will first define travel time measurement sections crossing the network in the east and west direction. Let's zoom in on the west section of the network. Left-click to select the eastbound entry link, and then right-click on the link on the red line near the red number 1 to define the travel time start section, shown as a red bar. Zoom out and then zoom in on the east section of the network. Left-click to select the eastbound exit link, and then right-click on the link on the green line near the green number 1 to define the travel time destination section, shown as a green bar. In the resulting dialog box, a unique number needs to be assigned to reference this travel time section. It is recommended to use a consistent numbering scheme throughout the VSIM network in order to easily reference the evaluations. The exact location of the travel time section can be specified. The distance between the start and end cross-section is determined by the shortest path. If no path is found between two cross-sections, the distance field will be blank. Often, this is a result of a missing connector or one of the cross-sections being placed on the wrong link, for example, in the opposite direction. You can also specify vehicle classes to be measured for travel time. The smoothing factor defines how a new travel time will be weighted along with the existing average travel time for online evaluation. Click OK to finish. We will add another travel time measurement section in the opposite direction. Left-click to select the eastbound entry link, and then right-click on the red line near the red number 2 on the link to define the travel time start section. Zoom out, and then zoom in on the west section of the network. Left-click to select the westbound exit link, and then right-click on the green line near the green number 2 on the link to define the travel time destination section. Click OK to finish. All the defined travel time measurement sections can be accessed by right-clicking outside the VSIM network. When you select a travel time section, the red bar and green bar associated with this section will be highlighted. Press Zoom to show the entire travel time section. Travel times can be displayed in a window during the simulation and/or output to a file. The window display can be enabled by selecting Evaluation, Windows, Travel Time from the menu. In the resulting window, average travel times will be displayed for each travel time section and updated with every completed travel time measurement. The file output can be enabled by selecting Evaluation, Files, Travel Time. Once the option Travel Time is selected, you can click the Configuration button to define the output format. In the resulting window, you can select where travel times will be collected among all the defined travel time sections and when travel times will be reported, including the starting and ending time and the time interval. You can also select if a vehicle should be counted to the evaluation interval by the time it crosses the start cross-section or by the time it crosses the destination cross-section. Travel times can be output to a file as compiled data according to the setting in this window, or as raw data, which lists every completed travel time measurement in the chronological order. You can also select to direct the output to a database with a specified table name. Based on defined travel time sections, vSim can also calculate delay by comparing the measured travel time with the theoretical travel time. The theoretical or ideal travel time is the time that would be reached if there are no other vehicles and signal controls or stops in the network. Delay times are generated for existing travel measurement sections. Therefore, no additional network coding is required. Each delay segment may include one or more travel time sections. Unlike travel time measurements, delay measurements can only be written to a file. To enable the delay evaluation, select Evaluations, Files, Delay from the menu, and then click the Configuration button to define delay measurements. In the resulting dialog box, click New to create a new delay measurement segment. Then select one or several travel time sections to be included in this delay measurement segment and vehicle classes to be measured. Here we define separate delay segments for each existing travel time section. If you uncheck Active, this delay segment will not be included for evaluation. Like travel time sections, you can specify the starting and ending time and the time interval for delay evaluation. You can also choose to output delays as compiled data or raw data to a file or to a database with a specified table name. Next, we will learn how to measure queue length information in vSim during a simulation run. To measure the queue length, we need to first define queue counters elements in the vSim network. The queue length is then measured upstream from the location of the queue counter to the final vehicle that is in the queue condition. If queues back up onto multiple approaches, the queue counter will report the longest as the maximum queue length. To define queue counters, first select the queue counters icon on the toolbar. Here we will place queue counters at the T-intersection in the middle of the network. Queue counters can be placed at any position on a link or connector, but the most suitable position is at the stop lines of a signalized intersection. Now click to select the eastbound link entering the intersection, and then right-click on the link on the blue line near the blue number 1 to place your queue counter. The queue counter is defined for the entire link instead of individual travel lanes. In the resulting dialog box, you can define a unique number to reference this queue counter and specify its exact location. Click OK to finish. Then, left-click to select the westbound link entering the intersection and place the second queue counter on point 2 as marked on the background map. We will repeat the same steps to place the third queue counter on point 3. After adding queue counters in the vSim network, you can activate the queue length evaluation by selecting Evaluation, Files, Queue Length. Once it is activated, you can access and set the queue definition by pressing the Configuration button. A vehicle is considered in queue condition if its speed drops below the begin speed and has not exceeded the end speed. The max headway defines the maximum distance allowed between two vehicles to be counted in the same queue, and the max length defines the maximum length of the queue, even if the actual queue is longer. It helps to separate queues spilled back from one junction to another during evaluation. Also, we can define the evaluation time as such from 0 to 3600 seconds at a time interval of 600 seconds. vSim also allows the collection of data on any single cross-section, much in the same way as point detectors in the real world. Data collection points are fairly simple to define. For example, to add data collection points in the T-intersection, we first select the Data Collection Points icon on the toolbar. Then, left-click to select the eastbound link, and then right-click on the link at the blue line near the blue number 1 to place the data collection point. Data collection points are always defined for individual lanes. In the resulting dialog box, you can specify the lane number, if it is a multi-lane link, and exact position where the data collection point is placed. Click OK to finish. Repeat the same steps to add data collection points for the other two approaches on individual lanes. If we switch to the centerline view, we can see that currently all the data collection points are placed on the link upstream from the turning connectors. By placing data collection points this way, we only have counts of vehicles approaching the intersection on each approach. If you need separate counts for each turning movement at the intersection, the data collection points need to be placed on individual connectors. To enable the data collection output, we will select Evaluation, Files, Data Collection from the menu, and then press the Configuration button to define the desired output parameters and data format. In the resulting window, you need to select the output format first. Raw data from the data collection points will record every vehicle's parameters to a file by the time step its front end passes the cross-section in chronological order. If compiled data is selected for output, you need to define data measurements and the data collection points they are composed of by using the New, Edit, and Delete buttons. Alternatively, you can press Auto, All, to generate one measurement for each individual data collection point, or press Auto, Groups, to automatically combine data collection points placed within 3 meters on the same link into one data measurement. Here, we define separate measurements for these data collection points we defined in the simulation network and set the evaluation time from 0 to 3600 seconds with the time interval of 600 seconds. The Configuration button allows you to select the parameters and output format of the data collection measurements. You can create new entries by selecting from the Parameter List box on the right. Depending on the parameters selected, the function and class-bound fields may offer additional specification. The selected parameters can then be added to the list box on the left, Layout of columns. Using the up and down buttons, you can change the sequence of the selected parameters as it will appear in the compiled output file. Finally, the data collection can be restricted to certain vehicle classes. The configuration will be saved to an external file, star.qmk. Here we select the number of vehicles, occupancy rate, and mean speed of all vehicle classes for data collection outputs. Click OK to finish. In addition to collecting data at a single cross-section, vSim also allows the users to collect data for a user-defined area within the simulation network. For example, by placing a node around an intersection, several output parameters can easily be collected without the need for manually defining multiple data collection points, travel time sections, and queue counters for each intersection. To enable node evaluation, we need to define nodes first. Let's switch to the centerline view so that we can see all the connectors and turn bays at the intersection. Select the node icon on the toolbar. To define a new node for the signalized intersection on the west section of the network, use the right mouse button. Click and drag a polygon along the black markers near the black number 2 on the background. Right-click again on the first point drawn to close the node. Once the node boundary is defined and the node evaluation is enabled, vSIM will automatically create necessary network elements for data collection. Travel time measurements are defined from all possible upstream starting points to the node exit point of the respective turning relation. Then, a delay segment is defined as a combination of all of these new travel time measurements. Q counters are placed on every movement found inside the node at the position of the signal head or priority rule stop line that is the closest one upstream to the node boundary on the respective edge. All of these automatically created network elements, travel time sections, delay segments, Q counters, are not available for user modifications because they exist only during the simulation run. To enable node evaluation, select Evaluation, Files, Node from the menu and press the Configuration button to select desired parameters for file output. Here, we will select to output the number of vehicles, average delay, and average number of stops for each movement within a node at each time interval. You can use the up and down buttons to change the sequence of the selected parameters as they will appear in the compiled output file. Finally, the data collection can be restricted to certain vehicle classes, and the configuration will be saved to an external file, star.knk. Click OK to continue. Node evaluation can also be switched on or off by pressing the Filter button. All existing nodes are listed in the list box in the middle, passive nodes. They can be selected and added to the list box to the left, active nodes. Here we include all nodes for evaluation and set evaluation time from 0 to 3600 seconds with a time interval of 600 seconds. The start of delay segment defines the length of the automatically created travel time sections. The travel time sections start at this distance upstream of the node boundary, but do not extend across the upstream node boundaries.